bear with me with 1 second. I couldn't find the mic for the podcast. Okay, Marina says this lecture hall might have a built-in mic. Oh, there should be one. Okay. Okay, let's get started. For this week's practice problem set, because we are in Wednesday today, which we have one more lecture to go. So we are just going to cover the today's lecture content and the Monday's lecture content, which are containers, reference, and parent class. So yeah, let me do the screen cap. So whenever you declare a variable of a certain type in Java, your computer assigns exact enough bits in the memory to hold that types. So example will be declaring an integer sets aside a box of 32 bits, and declaring a double set aside of 64 bits. So each bit is a container that contains the actual contents of the variables. So whenever I create a new variables, because in Java we tell Java what the variable type is, right? Whenever we create, we tell that it's an integer or it's a double. So Java can be smart that allocate the memory efficiently. So okay, you tell me that variable a will be an integer, so I will only set aside 32 bits of memory to hold that variable. So I cannot get this work. Sorry, bear with me 1 second. For some reason, my iPad is not picking up the screen mirroring stuff. Okay, anyway. So when creating a non-primitive type data object, so in the example, we are creating a primitive type, right? It's an integer, and it's a double. But non-primitive types, such as string, have several properties that we don't know the length of the string, right? The length of the string can be nothing. It can be 0, can be very long, can be a passage, can be a paragraph. So the way Java handles it, so it handles differently comparing with the primitive data types. So when we create a non-primitive data type, such as a string, Java follows a three-step procedure to complete object creations. What are those 3 steps? And what happens within each step? Any ideas?
It creates the 64-bit box for that variable.
Mm-hmm.
And then, I forgot what it does next.
Yeah, you got a first step correct, which is create a 64-bit for what? For holding what information?
Memory address?
Yeah, for the memory address. And then we went forward to create actual objects, right? For this example, we are creating a string so that we box the content of the string. For example, when I do so this is within the main method. When I do string str equals to DSC30. So the first step is we declare a variable called str, which that contains the 64 bits of memory address. And in that step, which is also known as, I'm going to pick up my solutions a little bit. The first step is called declarations. That is going to hold the memory address for the 64 bits for the pointers. And then the second step is called instantiations, that we are creating a new object of the specific type. So in this example, we are creating the object DSC30. The string itself is the content of the string. So the second step is we create a string that has the DSC30 in it. And the last step to complete this object creation, the third step is the assignment. So it puts the address of the new object into the new 64-bit box. So in the first step, it's string str, and Java creates a container that is 64 bits for pointers, and that's the first step. And the second step is we have another code. We create a new string called DSC anything. The second step is boxing this content in a string. And it will generate a 64-bit address. And the third step is this address will be assigned back to the str. So right now, the str, the variable itself, will contain a pointer to the inner memory address that points toward this string. Does that make sense? Yeah. Any question for the first part?
So for the non-predicted data type, we're gonna have 2 boxes, one for the address and one for the real value.
Yes. So that is actually the memory address is the pointers that points toward the locations in the memory. Because memory, you can think like it's a very, very, very long like a book, right? And it has address on it. And I could using this information is like this has a locations, so you could directly jump to a specific page to find the information I want. So it's like 2 steps. Yeah. Any other questions? My computer is not happy with me today. Okay, so for the second question, we have so in the first example, we have used the equal sign here, right? So in the lecture, we covered about the golden rules of the equals. So what is the golden rules of equals in Java or in programming language in general? Any thoughts? What does it do?
Assign one thing to another thing.
Yes, so assign which side of the equal sign to which side of the equal sign.
The left side to the right side to the left side.
Yes, so it assigns the right hand side, the left hand side. So it assigns things to the left hand side, right? So that's the golden rules of equals. So explain what equals does in each lines of the following code. Keep track of the value that each variable holds. Assume all codes are within the main method and are executed. So for the first line, what do we do? What does the equal sign do? Anyone?
It assigns the string DSC30 to the variable name DSC30.
Yeah, so what specifically the string is stored within the DSC30? What?
Sorry.
What is being stored in the DSC30? The variable. What is being stored here?
The string.
So it's actually storing the pointers to the string. So it's not storing the actual string. Because the string is very in length, right? Because we only have a specific amount of memory. For this case, it's 64 bits for holding the pointers. So it allows us to be more flexible because Java is rigorous. So it's not liking dynamic length. So it's Java handling those dynamic length in the memory address by using a pointer to the memory address. So in that way, you could store a fixed amount of the length in the memory address. So the first line is storing the memory address of DSC30 to the so in memory we have a string that contains the content of it's called DSC30, and the equal sign is storing the object memory address to the DSC30, the variable of DSC30. So the first line makes sense. And okay, let me erase this. So the first step is, so let's say this is my memory. It's like a long pages, like a lot of things. And it has a string called DSC30. And here's my variable. So right now it has a pointer toward that. That's the first step, right? Then what does the second say do? Second line do? Does.
So it replaces the whole address of the DSC30 to a new address of easy string.
Yeah. So let's answer using like a 3-step. So the first so right now we are not creating a new variables, right? So we are creating a new string called easy. So to write a new easy here. And then the equal signs store this memory address to these things. But the current DSC30 already has a memory address. What should we do?
Delete the old one.
Yeah, we overwrite it, right? So we remove this pointer and let the pointer point toward the new string. So in this way, DSC30 is lost. We are never going to recover the exactly DSC30 memory address again, because we does not have the contact or memory address to this location anymore. So this is lost. So you could think of this as Java has a memory managers that keep track of okay, this part of the memory I have something to reference to it, right? But right now, the DSC30, the string, does not have any variable to reference to it. So the system thinks it is drunk right now, so it will like actually remove it or mark it as like free memory. So it could be overridden by some other variables. So be aware of this phenomena, because later on when you're actually implementing the data structure, you actually want you might want to create like an intermediate stage like variable to hold this. So let's say we want to keep the DSC30 string, the reference to it. I might add an additional lines, that is string. We usually call this variable attempt, tmt, as a temporary variable, and let this variable point toward this. And then we do the second line, so that we keep one of the reference copy of the DSC30 while we assign new value to the EZ to the DSC30. Make sense? Any question upon this point?
When you say create a new one, temp equal DSC30, what we're saying is like it's not great another DSC30 and assign to temp.
So if I am creating a new string, you could see this new the creation of string is like a new string and some string here, right? Mm-hmm. So because like I said in the last discussion, Java developer thinks like whenever you create a string, it used to be that you have to follow this syntax. But they are thinking that, okay, this is too complicated. Whenever I want to use string, I need to type so many characters. So they make a shorthand, just use double quote. This is the shorthand of this. And then they are likely, it's more optimized. But the thing is, the point I wanted to make is whenever you have a new keyword, it is actually creating a new object for you, and you will have a new memory address. So if I do temp equals to DSC30, actually I will, in the memory, I will create another string called DSC30 and point toward that, right? So the trick to save the memory address for this DSC30 is not creating a new one. Is to equals to DSC30, the variable DSC30. So that the original content in DSC30, which is a pointer, is going to save from the right-hand side to the variable on the left-hand side. So the pointer got like copied. Yeah. Does that make sense? Any other questions? Yeah, I guess I just explained the length 3 and length 4 using that example. And the length 5 is what it's doing.
It's just a guess, but it's basically assigning nothing to DSC30.
So in the surface of it, the intention of that line is to set it as nothing. But in Java, we have a null pointer, which is also a 64-bit. That is like, you could think of it as like a special value, null. And it has a pointer, and you save the null pointer to the DSC30. Yeah. So null is actually a pointer. So that's the point. Any questions?
So if you set DSC20 to null, are they then pointing to the same null?
I guess they're pointing toward the same null. Yeah, I think so. Yeah, there is only one null. Yeah. Any other questions? Okay, let's see the solution I have. So I will, this PDF with solution, I will post it after discussion, and yeah. So the first one is create a variable that points toward the string, and the second one, yeah, basically it's what I do. Any questions? Yeah, okay. So the next question is, will this line cause an error? If so, what is the error? You can assume that the variable DSC20 has been initialized as a string. So if I do easy equals to DSC20, and I have been telling Java that DSC20 is a string, what would this happen?
That's not a valid variable name. You
Yeah.
can't use it to assign the left-hand side to it.
Yes, correct. So the golden rules of the equal signs says the right-hand side, everything on the right-hand side is being assigned to the left-hand side, right? But this cannot be changed. This is not a variable. So it does not have the containers or the boxes belongs to the this string. So it cannot be assigned. But it will have it will have a memory address, but it cannot hold the memory address. So that's the big difference. Any questions? So I actually put a little demo here. So if we do DSC20 equals to the str. So right now it highlights the red underline. It says something is wrong, and it is saying that the left hand side of the equal is expected a variable. So yeah, that's the gist of this question. Any questions? Any question in general about containers and reference? So a general tips when you are working with your PAs is remembering that each variables, if it's not a primitive type, you're actually working with memory address. So yeah, that's the thing you should look out for. And actually, to my mind, I just thought it's pretty useful so that, let's say I have an integer array. It's called int r. And I initialize it. I will let you predict what would this print out.
Memory address.
Yes, it will directly print out memory address because Java does not know how to handle the primitive type integer array. So it's like memory address. So if you really want to see the contents of the int r, there is a suggestion for you. So if you hover on that, there's a suggestion. It's called implicit call to string on an array. So remember in Python, in each class object has a toString method. So whenever you print something out in Python, you're actually implicitly calling the toString method and print out that string. And Java does not help you to do that, so you need to do that manually. So if I do arrays toString int r, it actually have an implementation to concatenate the actual content of the string. For example, the beginning bracket and the content comma. And if you run that code, I don't think you will be wrong. Yeah, sorry. Oh yeah, and the reason why it cannot be run is the one of the demo I have cannot be compiled within the project. So if you want to run your Java file, you need to ensure that every single class, every single .java file is compilable. Otherwise, you cannot run it. So That's interesting. Oh. Sorry, wrong different. Okay, it says 1, 2, 3, 4, 5. So yeah, that's a detour, just short detour. What's happening? Yeah, anyway. Any question for the first part? Okay, let's get to the interesting part for the inheritance and interface. So inheritance in Java, so the inheritance, the word itself is I inherit something from like my parents or some parent class, right? I got something like the same from the parents, from the like higher level from me. So inheritance include is a relationship between the parent class and their corresponding children class or subclasses. So in Java, a child class can inherit features, including fields and methods. So the fields means variables, the variable it might hold, and the method, which means the functions, from the parent class. The subclasses can have its own field and method other than inherited features, which means that it can be I can add more functions to the subclasses, and the subclasses can override method from the superclass. So I could actually override the content from the subclasses, add subclasses to tell the Java, okay, do this, don't do what my parent told me to do. Do what I wanted to do. So it's like override method. So the first question, so the first demo is abstract and interface can be understood as a contract or recipe of their corresponding subclasses. So interface, I get did professor cover interface in the lecture? Did? No? Is it Marina's or Sue?
Oh, I'm sorry.
Marina's Sue?
Yeah.
Yeah. Okay, quick recap, preview, some of you. Interface is like a contract, right? I told the Java, okay, so for this example, I created an interface, it was called these 3 topics. I have 4 topics I wanted to cover, which is the containers, reference, inheritance, and interface class. So, but I don't have anything here. I just have like a method signature here. So I just signing contract with my with signing contract. Okay, I will promise that these 3 will contain will implement or will go over those 4 topics, right? So it's like a contract. So when I navigate back to the D3 demo, if I do implement the 3 topics, so it implements the interface, right? Right now, I'm just telling Java, okay, in a class D3 demo, I promise to uphold with the contract that I signed with the D3 topics. So right now, Java is complaining because I haven't fulfilled my promises yet. The Java says that D3 must either declare an abstract method or implement the method that I signed the contract on. So again, IntelliJ is pretty intelligent. I will repeat that sentence every single time here. And Java actually helps you to do that. There is an implement methods here, and it pops out the window that tell you like, okay, here's four methods or topics in this case I wanted to cover. So right now, if I do OK, it will automatically put 4 different method signature empty in my class that allows me to fulfill it, right? So if I don't have those 4 topics in my concrete class, in my demo class, Java will complain and it won't compile. It will say that, okay, you haven't fulfilled the promise yet. I cannot go anymore. You have to fulfill the promise you promised. Any questions about interface? So usually interface is a very, very like short, concise list of the thing you wanted to do. So in this case, interface is just 7 lines, but it makes sure that every subclasses have those 4 methods, right? So for example, in this case, if a future quarter, another tutor want to do the discussion of D3. So let's say like the tutor want to like create a Java file to do that. So once so D3 demo is the version I currently use, right? I need to fulfill those 4 promises I need to make. To keep the consistency of the across the quarter, the teaching quarter, another tutor who is also going to implement the D3 topics will also have to fulfill those 4 promises. So it ensures that ensures that every D3, the third week 3 discussion get those 4 topics covered. So that's the beauty of the contract of the interface. Okay, so I will have a lot of question of would this cause an error and why? Usually they will cause an error, then the why is the most important part. So will this line code snippet cause error? And why?
Let's say yes, because it has a method body, but it's an abstract method.
Yes, so the abstract method cannot have a method body. So where's the method body?
It's just the 2 empty code.
Yeah, here is the method body. So method body can be nothing, but the curly bracket indicate that this is a method body. So the abstract method cannot have the method body at all. So because this is an abstract method, which is shown in this keyword, so it cannot have the body. So let's say study room is an abstract class. Will this line cause an error? This line is public class Geisel study room implements the study room. Will this cause an error? And what? Any thoughts? Okay, first of all, will this cause an error? Raise your hand if you think it will cause an error. Raise your hand if you think it is fine. Okay. Suspense time. This will cause an error because study room is an abstract class. It's not the same as interface. So there's 2 pairs, right? So in Java, it's some classes, class 1, implement an interface, or extend another class, include abstract class. So the reason why they will cause an error is because it's implement. Because you can only implement the interface. Yeah, correct. Any question? Yeah, would this cause an error? Raise your hand if you think this won't cause an error. Just remind you, the study room is this. Raise your hand if you think it will cause an error. Will not. Okay. Why will not throw an error?
Because study room is a class, and I don't
Okay. Anything?
Other than the fact that there's no body.
Yeah. And who for those of who will think this will cause an error, why?
It doesn't implement whatever that abstract method was.
Yeah, correct. So this will cause an error because it extends the study room, right? The study room is an abstract class. It's also like a contract assigned. So the study room,
You have to push it really hard.
the study room has an abstract method. And I guess I should delete that. Has an abstract method, right? It's called turn on light. And it has to be implemented in the subclasses. So if it is not implemented in the subclasses, Java will also complain that, okay, here's your promise, you haven't fulfilled it. Why didn't you implement that method? And it won't compile. And yeah, let's do a short demo. So here is a short draft of the study room, which is an abstract class.
Yeah.
As you can see, we have a constructor for that, and some method with method body, and an abstract method without the method body. So that is the contract assigned, and the contract comes with like a little method, predefined method. So I'm in the Geisel study room right now, in the class of implement that. So if I extend study room, Java will complain that you see the red underline. It says that class Geisel study room must either declare an abstract or implement abstract method. So if you can implement method, it will actually create an internalized method for you. So interface and abstract class are like a contract you sign. Yeah, and the subclasses must fulfill that contract, otherwise it won't compile.
So for the interface and the abstract, when we create a stain, we must implement at least those abstract or at least those methods that declare in the interface, right? As a minimum.
Yes, you have to fulfill those requirements, otherwise it won't compile. So it's so the benefit of this, so when you are actually implementing it, you might think, okay, this is so tiring, right? You need to implement every single method my parent class told me to do. I have to implement everything my parent told me to do. But when you're actually using your class, the beauty of the interface is that, for example, if I have a method toString, right? I can ensure that the class who the parent class has contract of toString must have that method. So when I do toString, I don't have like something like I don't know what to do because it is the contract, right? I have already implemented the toString, so I can use it. Yeah. Any questions? So yeah, I guess this is the last question. So will this cause an error for line 1, line 2, line 3? Let's analyze them differently. So if so, briefly explain why. So as a reminder, the study room is an abstract class. And the Geisel study room implementer. I'll just extend that. So will the first line cause an error?
No.
The very top line? Or the
Yeah, the first line, the line 1.
Oh, line
Oh,
one.
it won't cause an error. Should be fine.
I think it does cause an error.
Yeah. Yeah, the correct answer is it will cause an error, but why?
The study room was an abstract class, so you can't call like instructor on it.
Yeah. Yeah. So you cannot instantiate an object on an abstract class. Because abstract class is an contract. You cannot create a new contract. So, yeah. You cannot create a new object with the abstract class. Second line. Will the second line cause an error?
No.
No, why?
Because the Geisel study room extends the actual study room or the general study room.
Yeah, correct.
So doing it that way is right, but I think, and this is like a kind of a question, but if you switch or try and use Geisel study room and then do new study room, you can't do that, right?
So there's two explanations of why you cannot do that. First one is, first of all, you cannot instantiate an abstract class.
Okay, yeah.
And the second one is
But
you
even
cannot.
if it wasn't abstract.
Yeah, you cannot either.
Because it's the general.
Yeah, you cannot. You can only step up. You can because in this case, Geisel study room is a study room, right?
Yeah.
But you cannot ensure the study room is a Geisel study room.
Okay.
So you could, when you're creating, it's like you could only step up, but you're not only stepping down.
Makes sense.
Yeah. So the second line won't cause an error. The third line, what about the third line?
I'm guessing it won't.
Yeah, the third one is the most standard way we're doing things, right? Because we are both declaring that the 720 of the Geisel study room being a Geisel study room. Yeah. And another thing, because biomed study room here, you cannot declare Geisel study room to be a biomed study room. So you could only step up, but you cannot step up then step down. Because so whenever you are thinking about it, inheritance always encodes the is relationship, right? So if you have like a hierarchy of the class structure, you just parse the relationship into natural language. You could say that, okay, is Geisel study room a study room? Okay, it's a study room. But is a Geisel study room a biomedical study room? No, there are different things. Yeah.
So for the second line, the Geisel 719, that object can do all the method of study room or is Geisel study room.
So it cannot. It can only use the object on the study room, not the Geisel study room, because you are upscaling.
And you only do the parent one, not the child.
Yeah, you are losing it because you are losing the specification of the children class. You're stepping.
So the line 2 is possible, but it's like, what is the purpose of line 2?
Oh, yeah. So the purpose of doing this line is being flexible in Java. So let's say I give you an input, right? I will let you to give me an input of. So let's say you are reserving a room, and you're reserving a study room, and I asked which room. I ask you which room. You should give me either this or this, but I accept both, right? That's the beauty of it. I can accept the children class of this as a more flexible way, because so that I don't need to implement two systems that only takes a reservation for only Geisel study room, and so I'm creating a system that can handle both.
Yeah, because I remember the lecture this morning saying that the purpose of line 2 is like, if we do that way, we can put multiple reference object into one array.
Yeah, you could do that too.
And then when we call the method of the child, it does the different behavior also. Like if for Geisel 719, it will do something special, such specifically for Geisel study room only. And when we have another one, study room Genzo 720, it will do something called 720 only. So it is accessible to the child method, from my understanding.
Yeah, I'm sorry. I might be a little rusty on this. Yeah, it might be. I will make a follow-up post on this. Okay.
No.
Yeah, because another advantage of this is you could pack every single study room into one array, so keep track of it. Yeah, I know this is confusing. I sometimes mess it up too. I'm sorry.
No problem.
Yeah.
Thank you.
Yeah. Any other question? Yeah, if no, I think we're done, and I will stay here for 30 minutes for a question.
I'm confused on why this would be 2, but if you just do the normal way, this would be 10. Go up to 2, but this one was 10.
This one should.
But the, so the method is like it's study.
I have the
Yeah, they're not gonna ask us to do a hard code.
But it's still you have to code by, right?
Yeah, but it doesn't like. They're just gonna not that many, and according to her, they're not many.
Yeah, I guess the reason why of it is everything in here is in a static. So static method is
With Java, that's another
you
different.
could think it as a static thing.
So they don't wanna make creating them
So
look
the
for
I
like.
has to be,
yeah.
and so there's no scope anymore because static is like a
It's a
huge
50-minute
compile
exam.
of everything. So if you change array I, you're actually saving the I.
So should I focus on the DY?
She said,
I'm confused. Okay, I'm sorry.
she said like.
So this should go to 10, right?
No, it's up to 2.
2. Okay. So the array I is. I can activate. So I messed up. I thought this was the main method. So let's say I create an I, which is an integer array, and that would be.
Thank you, Scott.
You're welcome. And
Thank you,
then
Scott.
right. And I right now.
Oh, where am I going?
Thank you. I've had discussions here.
It's 2, right?
Yeah.
Yeah. And then if you do this, you're creating a new variable I inside. So it's passing by the memory address reference, right?
Right, yes.
So it's here. It creates a new variable called I within this change array method. So I have an I right here, which points over here, which is within the main method, and within the main method I change array here, and I have a different I here. So it's within the different scope.
Why is it a different I?
Because
Because I'm confused because here you have this I,
Yeah.
which I understand has one memory. It's
So-
referring to the memory. Oh, no, I mean, this one has I, it's referring to memory address of this. Then you're passing the same I into here.
but it's a duplicate of I. So this I is different from this I. So this question is intentionally meant to be confusing.
Okay.
So if you change I into something else, for example, into R, it will make it more clear. So if you want to change the I into R,
Okay.
Can I do that?
Yes.
If you mind?
Yeah.
My hand is dirty.
Oh, you have to just do it.
If you do int r, I actually don't change anything, right? Because I just changed the naming of the variable. So right now it's within the method it's int r. So it's not to be confusing with the original r.
Okay.
So right now I do this. So the memory address of the I got copied into the int r, right? So int r right now pointed to this array of 2, right? Correct?
Yes.
So let's start from the top. So the first I
Yeah.
has length of 2 with 10 and 20.
Great.
And then within the another method, which is another frame, I copy the memory address of I to int r.
Okay. Yeah.
So right now the int r points to a right?
Okay. Yeah.
And then this line,
Yeah.
I erase this pointer and let it point toward a new thing.
Okay.
So it's a int 10. It's an empty array of length 10, right? And so this method ends. So this got erased.
Okay.
So the original I still point toward this.
Oh, so what you're saying is that int r is being assigned to this variable almost.
Yeah. So if you are doing int
That's
r equals to I, but not I equals to int r. So you are assigning a memory address from the right hand side to the left hand side.
Got it.
So you did not change the pointer of I.
Okay, I was thinking it the opposite.
Yeah, it's confusing.
Okay, thank you.
Okay, well, 对，这个的话，首先第一个它是这个前面没问题，我可以把一个 variable 设置成一个 abstract class 的 type，但是我不能 instantiate abstract class，which means that new 后面不能是 abstract class。
但是那我会不会那这个305是在上面？
我的用是 abstract。
那这个 Gazelle 是属于 ethnic 的。
对，跟 Gazelle 是一个 concrete class。
所以就可以。
你可以去 create a concrete class，but not abstract class at that point。concrete class 就是 not abstract class and not interface，it's not a contract。就是所有 class 是 concrete class，就是没有那个，就像这样 public class 就是 concrete class。 因为 concrete 的意思是它是实心的，它有东西，它有 implementation。然后 it's not concrete abstract 和 concrete 应该是一个反义词嘛。然后 abstract class 就是。